Hi everyone, thanks for joining us today on our talk regarding sharing the wealth, socializing Kafka event sources in an organization. Today, we will be talking about how we've been using AsyncAPI as a way to enable event source socialization. We will also be talking about the challenges that we've been facing with regards to some unique Kafka use cases when using AsyncAPI. My name is Nick Townsend. I've been a developer with IBM for 10 years, and for the past 4 years, I've been working on Kafka-based solutions. With me today is my colleague Salma.
Hi, my name is Salma. I'm also a software developer working at event and project management at IBM. So let's start with a story and talk about streetlights. So you might be familiar with this example, as is the same example on the AsyncAPI website. So we have Ava. She is a developer and she's just joined Smarty Lights. So Ava's manager has assigned her a task to build an application that will process the events that come from all the different streetlights in the area. And based off environmental conditions that those streetlights are reporting, the application will need to take an action, such as turning them off or raising a help ticket. So Ava thinks about it and she realizes the data coming in is essentially a series of sources of events. And so she begins to start thinking in a Kafka type approach. So Ava starts to build her application, but Ava soon realizes that there is no streaming data available for the streetlights. So Ava goes ahead and writes a Kafka connector that can connect to all of the different light APIs, pull in the data accordingly, and then push into Kafka. So this allowed her to run through some stream processing, make some decisions, and then start switching off the lights accordingly. So Ava knows Kafka, but isn't too experienced. And so it takes her a couple of weeks to get the application working, but she did it. But sometime later, Ava talks to Nico, and Nico is in a different part of the organization. But Ava mentions the work that she's doing, so creating this new application using Kafka, and talking about some of the challenges that she was finding. But Nico asks, why were you doing any of this? We already have an event source available in our Kafka cluster that is pulling in all of that data. So if you just had consumed from our topic, you wouldn't have needed to go through all of the setup that you went through. So Ava is now reasonably frustrated and she realizes she has just wasted a lot of her time on this and wish she could have easily found out these topics existed before she spoke to Nico. So to try and help, Nico sends Ava some details about the application they have. He gave her an architectural diagram that explains the different producers and consumers that are involved in his application that ultimately result in some data about the streetlights being put onto the Kafka topic. So Ava has all these details about the internals of the application, but most of these producers and consumers means nothing to Ava. She isn't interested in that set of the data, and it takes a while for her to read through and understand it. But she finally realizes that she needs to look at one of the light topics. So now that she understands which topic she needs, she then gets on with the next part of the application. She no longer needs a Kafka connector and can go directly to Kafka to retrieve the streetlight data from the topic. But as she starts to do this, she realizes she doesn't have any idea of how the structure of those messages should look like. The format of the messages were not what she was expecting, and there was nothing documenting the schema. So Ava is feeling super unhappy and wishes that she knew what Kafka cluster and topics are available for her to use in her company. And when she finds the topics that she wants to use, how can she understand the data that is on them? And how can she start using these topics as efficiently as possible?
So we started to think, how could we make things easier? We've seen users and our customers facing these problems as they've been developing Kafka-based event-driven architectures. And we started to think, what could we do to help them? How could AsyncAPI allow us to enable a significant improvement to the user experience? As Salma mentioned, Ava was looking at the document and she was only really interested in the one topic. This could be considered an external API, an external set of data that Nico could have shared with everybody. He didn't need to share all of the internals, which risks confusing everybody. Instead, he just needed to document the fact that this topic existed, containing this data that other teams should be willing to consume. So instead of the impromptu meeting in the tea room where Nico and Ava had their conversation, what if Nico had actually published the information regarding this external topic to some form of catalog. He could have used AsyncAPI as a way to document the Kafka server. He could document the structure, and he could document any form of metadata that would be useful to explaining the particular API and data on that Kafka topic. Ava could later have then been searching through this catalog when she realized she needed to access the Streetlights API data. She would have been able to find that there was already a Kafka source available for her to use. Not only that, she could then have downloaded an AsyncAPI document, which would allow her to be able to start to configure her producers and consumers. Even better, by taking an AsyncAPI document, she would have been able to use a series of generated tools to actually build a Bootstrap application that would consume the data from the topic. So at this point, she has simply been able to take an async document and generate client application. This is significantly easier than the workflow that we had Selma walk through earlier.
Well, we have implemented this scenario that Nick has just spoken to, and it's powered by AsyncAPI. So what this means is we are able to start rendering authoring experiences for both the developers and API consumers. We provide the capability of an API manager, as you're seeing on the screen, to allow users to document their Kafka topic using the AsyncAPI format, as well as being able to edit and publish it. So here you can see we have this form for users to fill out and upload to in order to create their AsyncAPI document with ease. And once they have created their AsyncAPI document, they then have the ability to edit their document. So editing their document allows them to add in more information. So as well as that, we also give the source view, so they are able to learn about AsyncAPI along with it. So we are using AsyncAPI as the document structure whilst authoring this API to describe Kafka. And in the same respect, we then use the published AsyncAPI document as a way to render a catalog where people like Ava can search and find them easily. So here you'll be able to see the async API that was just created and has been published. So if we move on over to the portal side, and this is where we socialize the async APIs. So Ava will be able to easily search and find the API she is looking for. So we render developer-friendly features based off the contents of the async API, and additionally we provide the document as a way for Ava to download, if she is a power user, to use the document with her favorite generator tools. So in this case, as you can see, we are generating some sample code for Kafka users.
Having shown you how we've been able to use AsyncAPI to provide the event endpoint management capabilities, the next thing is we'd like to discuss what's been challenging us today. So as part of adopting the AsyncAPI spec, there are some gaps when it comes to Kafka-specific behaviors. One thing I'd like to talk about is the idea of a Kafka Bootstrap server. So Kafka is configured with a property called Bootstrap servers, which is a comma-separated list of all of the servers that can be used for clients to initially bootstrap their connection. Kafka uses multiple servers as a best practice to allow for failover. This means that if a client is unable to connect to one of the Bootstrap servers, it can then try a connection to another Kafka broker in the same cluster to ensure that we have failover and high availability. So looking at this snippet of the async API document, we can see that there are two servers. It's named Bootstrap 1, Bootstrap 2. Both use the same security, both use the same protocol. So our first guess as a human reader would be that we probably should be able to combine these two into a single Bootstrap servers list when we write our Kafka application based off the specification. But what about these two? They have the same protocol. They have the same security type. But they have two different URLs and they have two different labels. They have a production and a test label. Now, to a human reader, we would assume production and test mean they are two separate servers. They probably are two separate Kafka clusters entirely. But this isn't obvious when parsing the spec. Those are just two labels. They have human metadata, but they have nothing to describe them for a machine generator to use. And then finally, we also have this scenario. Both the brokers have a similar looking label. There's different URLs, but that's not unexpected for a Kafka broker, especially if there was a load balancer involved. They both have the same protocol, but they don't share the same security. So the question is, how can we actually work to improve the spec to ensure that these kind of scenarios can be catered for? So there is currently an issue of open at the moment, issue 65, starting to discuss this. And the question is, do we look at perhaps grouping the servers by function, adding in metadata that allows us to identify when generating code, which server is in a pool, i.e. the same cluster, to be able to be used in a Bootstrap servers list? Or perhaps actually we take this in a different direction, and maybe we should be looking at using validation on the specification to ensure that we have a fixed combination of protocol and security. So by that, we can simply say, if there are a series of Kafka servers using the same protocol and the same security mechanism, then we assume that they are the same Kafka cluster and apply them to Bootstrap servers. But this is where we need your help. We'd like to accelerate this issue, but we aren't the entire experts. We want the community to help out. So if you have strong feelings about this, please could you start to contribute to the issue and help us to get through this challenge. The next piece I'd like to talk about is payload encoding. So in a specification, we can define the payload, we can define a schema for it. In this case, taken from the Streetlights API, we can see the three properties that are used in the message payload: an ID, the lumens, and the send-tap time. So what does this tell us? Well, it tells us the shape of the message, and it tells us the validation that will occur on the field values. We have minimum values or we have a particular format. But we need more than this for Kafka. What we need to know is how this message ultimately gets stored in Kafka. And what do I mean by stored? Well, in Kafka, data is stored in bytes. So a producer will produce messages in byte stream to Kafka brokers, and a consumer will consume those messages as byte streams back from the broker and the topic itself. So the producers themselves and the consumers need to have a way to speak and convert words, data into a byte stream. And that's the concept of a serializer and a deserializer. So if a producer is configured to say that its payload will be sent through as an integer, then this serializer class is used to convert the integer into a byte stream. And as long as the consumer knows that it is speaking to a topic that has been populated with serialized integers, then the consumer can be configured to use the same deserializer and ensure it gets the right value back. But the problem is that if you can't communicate this, then the producer and the consumer could get in a point where they are using mismatching serialization library classes. So what this means is that if a consumer thought it was trying to get a string, it would be getting data back out of Kafka and serializing it into an object that made no sense. So given the previous example with our Streetlight specification, we know the shape of the message payload, but what we don't know is how it's serialized onto the Kafka topic. What we could start to look at using is the schema formats that exist in the AsyncAPI spec. By using the schema formats, we would at least be able to tell whether or not it was Avro or JSON or an AsyncAPI document that was used to create the schema and would be used by the producers and the consumers when converting from the byte streams. But this isn't the whole picture, because in Kafka, as I said, it was byte streams, which means not only do we need to know whether or not it's an Avro or a JSON schema that is being used to create the objects, we also need to know the type of encoding as it's being put onto Kafka, i.e. what will the serializers and deserializers look like? We could look at using the content type as part of the message. So if we said it was an application JSON, then we at least could infer that perhaps it's a string serialization of JSON going onto the Kafka topic. Maybe we could use application octet as a way to represent binary, meaning that in particular, say with Avro, it's actually being encoded in binary when it's sent over the wire, and therefore you need to decode it using an Avro binary decoder to get the message content back out. So what this means is that we could use an async API document with a producer and with a consumer, parse the document, and look at the schema format and the content type. This would allow us to infer that we probably do need an Avro JSON serializer and an Avro JSON deserializer on the other end. But the challenge with this is that we are inferring a lot. So the question is, do the options for content type mean the same to everyone? Does application JSON mean I'm using the JSON encoding in an Avro serializer? Or does JSON encoding mean I'm serializing through simply a string? And the same with binary. Does the binary mean, does octet, sorry, as binary mean binary, or does it mean something to anybody else? So our thoughts are perhaps we need to look at a Kafka binding as a way to identify the encoding. By that, I mean a specific Kafka binding on a message to give us a list of acceptable enums purely for Kafka. This would take away the ambiguity, and it would allow us to then ensure that producers and consumers could agree on the correct way to serialize and deserialize back from a schema object. I'm now going to hand over to Selma to discuss some further challenges that we're facing.
Right. Let's talk about schema registries. So Kafka uses the concept of schema registries, and a schema registry is a central place where producers and consumers can look up a schema, and they can use the schema as a way to serialize and deserialize objects onto the Kafka topic. But there's a problem. The producer and consumer need to know which schema ID should be used and when it wants to read or write to a message to Kafka. So in order to be able to go to the schema registry, it has to be configured with a schema ID. So we could use the $ref field as a way to define the message payload with a URL to point to the schema registry. However, with the $ref, you can identify where the schema is, but the question is, how do you communicate back and forth? Because although you have the URL, this doesn't actually tell you the vendor. So what is the API like? How do you know how to connect and consume from it? How do you write a producer and consumer that can speak to the schema registry in the right way to actually retrieve the schema? So to solve this, you will need to identify the vendor in a Kafka binding, but it also means you will need to write a custom producer or consumers for each vendor API. Well, actually, schema registries tend to come with their own clients for accessing this to solve part of the problem for us. So schema registry clients are already configured to know how to talk to a schema registry, and they are configured to know how to look for the correct ID in a Kafka message to be able to understand which schema was used to create it. However, there are multiple approaches to embed the schema ID information in a Kafka message. So in Kafka, an individual event is called a record, and a record is basically a key and a value pair. So keys are optional in Kafka, and so the bulk of your message goes into the value. So the key provides some additional information that Kafka can use for routing and things like that. So we would have this key and value, and there are two different ways in Kafka of how you can send across the schema ID. And one approach is embedding the schema ID in the record. This is using something called a magic byte. So imagine this is the bytes of a value of a record that has been put into Kafka, and the value has been updated. So it includes this magic byte. And what this means is that The producer sends this through Kafka, and when it is received by the consumer will be able to deserialize this message, and it will split it into 3 different parts. The first being the magic byte. So this is the additional bytes at the start of a Kafka message before the serialized data. So this magic byte will be a way to identify that this will be containing a schema ID. And the second part provides the integer schema ID. So this is a way to uniquely identify the schema that is being used for the message. So when the consumer receives the message, they will use this ID and they will go fetch that schema, and they will use that schema to go and deserialize the message. And then the final bit is the rest of the data. There is an alternative way to send the schema ID, and this is with record headers. So as mentioned before, in Kafka, we have a specific record, which is made up of a key and value, and Kafka have also recently added a record header. So this is the concept that has been included in a lot of different messaging systems over the years, and it's this idea of having additional metadata that can pass through with your message. And so the client will be able to read the schema ID from the header and retrieve the right schema from the schema registry. The problem is, however, different schema registry vendors have made different decisions. So looking at Confluent, they encode the schema ID using magic byte format, placing 4 bytes into the byte stream before the encoded data. Apicurio, however, have 4 different ways of approaching this. They either allow you to put it in the headers or allow you to put it into the message. But in addition to this, they also have 2 different ways of storing the ID, and one is an 8-byte long and one is a 4-byte integer. So how can we solve this problem? Well, we need vendor-specific bindings to be able to identify configuration for the vendors. So although you can say download the Service client, you will still need to know how to configure it. So is it speaking to headers? Is it speaking to the ID? These are the vendor specifics that will get put into the spec.
So in summary today, we've discussed how socializing events will save Ava time, effort, and sanity when consuming from Kafka topics and discovering new sources of data. We've shown how we've been able to use AsyncAPI as a way to provide an endpoint management capability that results in governed catalogs of sources of Kafka data for users to discover. But as we've also discussed, AsyncAPI does need to evolve to enable us to reach the full potential of these Kafka events. There are Kafka-specific features that need consideration in the specification, as we've highlighted today. So hopefully, we've been able to communicate our concerns and our ideas for the future, and we would really appreciate your help in fleshing out some of these issues and contributing additional ideas to allow us to get these capabilities added into the AsyncAPI specification. So thank you very much for your time. And we will now answer any questions that have been asked on the chat.